Okay, for this video I'm going to talk about exponential growth and decay. That can be found in the form of y equals a times b to the x. If the b value is bigger than 1, we're going to have exponential growth that goes up like this. If the b value is between 0 and 1, then we have exponential decay. So let's give a couple examples, real-life examples of exponential growth and decay. First one, Joe bought a new iPad for $600. Each year the value of the iPad decreases by 25% of the previous year's value. At this rate, what can Joe expect the approximate value of the iPad to be after 6 years? Well, let's first write a function in the form of y equals a times b to the x. The initial amount that the iPad was worth was $600. That's our a value. So 600 times, and now since it's going down, that's an actual decay. It's going down by 70%, 25%. That means that he retains 75% of the value each year. So I'm going to multiply this by 0.75 to the x. When I put in 0, I would get the initial amount of $600. That's what it starts out with. I want to know the value after 6 years. So after 6 years, I would go y of 6. And I plug 6 in for the x. So it's going to be 600 multiplied by 0.75 to the 6th power. So now I go ahead and I type this into my calculator. I can type in 600 multiplied by 0.75 to the 6th power. And I get a value of $106.70. If we rounded it, it would be 79 cents. That's the value of the iPad 6 years later, based upon the decrease in value that we were given. Okay, so there's exponential decay. Let's look at the next example. The next example says the population of Williston started with 4,000 people in the year 2000. Each year the population grew by 20%. Write an equation that represents the population of Williston T years after the year 2000. So we're going to, again, use the form y equals a times b to the x. This time we started out with a population of 4,000 people. So we're going to use 4,000 as our a value. Then our growth rate is growing by 20%. Because it's more than it's growing, then the b value has to be more than 1. So you go 1 plus 0.2. So that would be 1.2 is the growth rate. And we're going to do it in t years, so I use t instead of x. Then it says predict the population of Williston in the year 2016. Well, because this equation is based off of the year 2000, I would say, well, that's 16 years later. So then all I do is I do y of 16, which is 4,000 multiplied by 1.2 to the 16th power. Then I take out my calculator, I type this in, 4,000 multiplied by 1.2 raised to the power of 16. Okay, so now the population would be 73,953.7 people in the year 2016. Okay. Technically speaking, then, if it says if they said round to the nearest person, then you'd say 73,954. But you could also argue, technically speaking, that that fourth person isn't there, so it'd be 73,953. All depends on how the question wants you to answer it as a decimal. This would be an example of exponential growth then. So this is an exponential growth. The iPad problem was an exponential decay problem.